Hey guys, welcome back. Welcome to the fifth and final installment in my series on pointers in C++. In this video, we will be discussing dynamic memory allocation. Okay, up to this point, all the memory allocation that we have used has been static memory allocation. Okay, static memory allocation occurs at compile time. Okay, any variables that you define are going to be allocated, the memory for them is going to be allocated when you compile the program. Right? Dynamic memory allocation is different. Okay, with dynamic memory allocation, we're actually allocating memory at runtime. And that is to say that when the program is actually running. So what I'll do to illustrate dynamic memory allocation is I'll write a function that uses dynamic memory allocation to resize an array. Okay, what we're going to do is we're going to pass it an array and add values to it. And if there's not enough space in the array anymore, we'll to fit the new values that we want to stuff into it, we'll dynamically allocate a new one that's twice as big. Okay, so let's do that. Let's go ahead and get started. Okay, so let me just start by giving you an overview of how you can dynamically allocate memory. Okay, so we use pointers for this. No surprise, I mean this is a series on pointers. And so what we do is we are going to make use of a new operator, and the name of that operator is new. Okay, and it is responsible for returning the memory address for the location of the newly allocated memory. Okay, so we can allocate memory dynamically for regular variables, right, like integers or characters, but we can also do it for arrays. Okay, so let me show you how to dynamically allocate an integer. Okay, so we're going to need a pointer. So let's say that we're going to dynamically allocate an integer. Right, we'll just call this int pointer, and we're going to assign it the memory location of our newly allocated memory. So new int. Okay, that's what we're going to do. Okay, so this will create a brand new int variable that we can access via this pointer. Okay, so this creates it. Now if I want to assign an integer to this memory location, I use the indirection operator. Okay, and then I can assign it a value, say 5. Okay, and then I can use the indirection operator, return that value, send it to cout, for example. So let's run this, and you'll see that works just great. Okay, the difference is that this was created, this memory was allocated at runtime. Okay, now in C++, we have to perform something known as garbage collection. Okay, so as it turns out that whenever we dynamically allocate memory, we have to deallocate it before our program finishes executing. Okay, if we don't do that, every time we run this program, this memory location for this dynamically allocated memory, it stays allocated even after the program's gone. So if you run this program enough times and it allocates enough memory dynamically, eventually the space that your program's running in is going to run out of memory. Okay, and so you won't be able to run your program anymore, or you might have an operating system crash, bad stuff happens. So it's up to the programmer to make sure that he takes out his garbage. He does the garbage collection. Okay, we have to deallocate our memory. If we don't do this, you get what's called a memory leak. Very bad stuff. So to deallocate a standard variable, we use this other keyword called delete. Okay, so in this case, I want to delete the memory location that is being pointed to using my int pointer here. Okay, so there's the keyword. Okay, so we use delete. This is used to deallocate dynamically allocated memory. Okay, and it's also good practice after you delete, anytime you delete dynamically allocated memory, to set the pointer to 0. Okay, 0 is an invalid memory location, so if we do this, we're sure that our pointer's not pointing to some random location in memory. Okay, so set to 0, it's set to null. We can't accidentally use that pointer to access locations in memory we shouldn't be messing around with. Okay, so I mean, I could do this with integers. I could do this with characters. Okay, so let's assign a value to character pointer, for example, and then I'll see out the value stored in the memory location that character pointer is pointing to, which is our newly allocated memory location. Right? We use dynamic memory allocation to do that. Okay. Then I want to, after I'm done with that, I want to delete it, and I want to set the pointer to 0. Okay, so let's run this and we'll see that it works just great. Right? So there's the value, the dynamically allocated value that is stored my integer in, right? 5, that integer location, A for the character location. I deleted everything when I was done with it, being a good citizen, and then I set my pointers to 0 just to be safe. Okay. All right. So that's great for normal data types, but we can also do this with arrays. Okay, and this is kind of where this kind of shines, or a little bit more useful. Okay, and later on we're going to find out that we can dynamically allocate objects that we're going to create ourselves. Okay, and that's kind of a big deal too. But we could dynamically allocate any data type. Okay, so let's do it with arrays. Okay. So let's say that I wanted to dynamically allocate an array of doubles. Okay, so I have to make a pointer. We'll call it double pointer. Use this new keyword, but my syntax is going to be slightly different. Okay, the data type is double, but now I have to specify how many elements are in my dynamically allocated array. So I use array notation to do this. So let's say that I want an array of doubles that has 5 elements. Okay. All right, that's the syntax. Okay, I just add the array operator and I specify how many elements I want in here. Okay. So now I can use my pointer here to interact with this dynamically allocated array just like I would any other array. Okay. So I can say double pointer 0. There, I've just assigned 2.5 to the first element. I could use pointer notation. Right? Double pointer plus 1. Right, equals 3.5. Okay. I could use pointer. I could use array notation and arithmetic to assign to the third element the sum of the first and second elements. Okay. And I could even, print all the values of the elements, stored in elements. I less than 5 plus plus, cout, double pointer I. Okay, and we'll throw the end line there. So let's test that. Okay. So 2.5, 3.5, 6, 0, 0. Okay. 6 being the sum of 2.5, 3.5. Okay. So if you don't fill in all of the values, right, when you print them out, it initializes them to 0. Okay. So the initial elements, the values stored in the elements of your array, are going to be set to 0. Okay. All right. So memory leak's still a concern with arrays, so we're going to have to delete our array after we're finished using it. So we'll go down here. Okay. But the syntax is slightly different. We're dealing with an array here, so we have to add the array operator here. Okay. Otherwise, everything else is the same. Okay. Set our pointer to 0. Okay, why do we have to have this array notation here? Because when you're dynamically allocating an array into memory, right, there's more than one memory location. Remember, arrays are a sequential list of memory locations. So we need different syntax to indicate that, right? If you just did delete double pointer, either you'd get a compile time error, or you would only end up deleting the first element of the array. Right? The remaining elements would still be allocated, and that's not what we want. So we have to remember to use this notation here to deallocate arrays. Okay, so make note of that. Delete. Right? This is used to deallocate dynamically allocated arrays. All right. So now I've kind of given you an overview here of the syntax for dealing with dynamically allocating variables and arrays. So let's do an example that's a little more interesting. Okay. So let me delete this stuff here. Let me get this out of the way. And what we'll do is we'll write a function that will dynamically resize an array that has been filled up that we want to add another value to. Okay, so let's call this thing expand. Okay, so what we're going to need to do is we're going to need to pass it an array. Okay, it's going to be a dynamically allocated array. So we're going to use a pointer parameter. Okay, so let's just, for this example, let's just make it an integer array that we're dealing with. Okay. All right, so we'll make it an integer array. We'll need to have an integer for the value that we're trying to add to the array, and then we're going to need an integer that tells us how big the array that we're passing to the function is. Okay, and we'll make it a reference parameter because once we expand the size of our array, we're going to have to update the size value that was passed to it. Okay, we have to make sure that that's up to date. So we'll use pass by reference. We'll use a reference parameter to deal with that. Okay, so this function adds the function adds a value to an array and expands the array if it's full. Okay, we'll double the size is what it's going to do. It's going to resize it. Okay. All right. So let's do this. All right. So let's just call the array R, right? The parameter list. Let's call this just value, and we'll do size here. Okay, we'll just call this. Well, let's call it length. Okay. So now we're ready for our definition here. Okay, so we'll just have it, what we'll do is we'll just have it expand, and we'll just have it add another element every single time we add a value to the array. Okay, so the algorithm's going to be something like this. It's going to be, let's see here, dynamically create a new array that is length plus 1, right? We have to add an extra element to the end of this thing, okay? And then what we need to do is we have to create, or we have to copy all the values from the old array to the new one, okay? So we have to preserve the old values, and then finally add the new value to the end of the array. Okay, so the way the array is going to work, it's just going to add an element each time we want to add a value to it. So this thing is just going to grow. It's going to expand as we need it to. Okay, so let's start by creating our new array. Okay, so there's our algorithm. It's a 3-step algorithm. So we're dealing with integer arrays for this example. So just call it new R, okay, for the new array. Okay, equals new int, it's an integer array, and then length plus 1. Okay, so that'll create a brand new array that is one element larger than the old one. Okay, so let me change this to let me change the name of this to old array so we can keep it straight. Okay, and let me make this a little more descriptive. This is the new value, okay, that we're adding to the end. Okay, so now we have to copy all the values from our old array to the new one. Okay, so for int I equals 0, I less than length, right? That's how long the array is. Now let's just do an element by element copy. Okay, set to old array. Right, so that'll do that. Right, this is a for loop that hopefully looks familiar. Right, hopefully this is something you saw in 1160. Okay. So finally what we have to do is we have to add the new value to the end of the array. So new R length, so should put it at the end, equals new value. Okay. Alright. So I think that's going to do everything. Oh, we have to update the size of, or the length here, right? We have to update this because our array is larger now. Okay, the array we're returning is larger. Okay, so let's do length plus plus. All right. So I think that'll handle everything. This is like pass by reference. The problem is that let's think about this for a second. Okay, well, how am I going to do this? What I want to do is I want to replace the old array here. Okay, that's my thinking. Right, so I can't just copy it. I can't just do this. Right, we might be tempted. You might be thinking, well, why don't we just do this right here? Okay. Well, as far as main's concerned, that would be kind of like what we're hoping to do. The problem is that the pointer, okay, in main that was pointing to the old array, now it's pointing to the new array, but the old array is still out there. Okay, so this isn't going to work. If we did this, the old array, we would lose our handle on it. It would be in memory somewhere, but we could no longer access it. So this solution isn't going to work. Okay, so how about we do this? How about we delete the old array? Okay, we can do that because we're done with it. There's no reason to keep it around anymore, so let's delete it. Okay, delete the old array because we're done with it. Okay, but we still have to get the new array back to main after it's done calling expand. So how about we just return the pointer to it? Why not? Pointers are just like any other data type, right? We can return that. So let's change this here. Let's change this void function to return a pointer. Okay. So now what's going to happen is that once this array is created, we've done the copying, right? We've tacked on the new value to the end. We've deleted the old array. We've incremented the length, right? So main knows how long the new array is. Then we can return the new array, new R. Okay? We can hand the newly created array, the new version with the new value tacked onto the end, back to main. Okay? So let's look at a function call for this. Okay? So let's just make a pointer in here. Okay, so int star, we'll call it old array in here too. Okay. All right. Let's initialize that to null, and then let's have a value here that's length, and let's initialize that to 0 also. Right. Right now there's no array. We don't have an array. Okay. But we haven't tried to add anything to it yet. Let's make it so that we can ask the user for a value. And the first time the user is asked for that value, first time they enter a value, a brand new array will get created, and it'll add the integer to it. And then we'll just keep looping over and over again, asking them for new values, and our array will basically grow. Right? Not really. I mean, what we're doing is we're killing the old. We're creating a new array, copying all the values over, tacking on the new value to the end of it, and then deleting the old one. So we're recreating the array multiple times as the program's running using dynamic memory allocation. Okay, so let's write a do while loop for this. Okay, so do while input, we'll use a sentinel, does not equal negative 99. How about that for a sentinel? Negative 99. Why not? Okay. So we're going to need an integer here for input. Okay. And then we're going to need to ask the user. Cout, enter an integer. Okay. Then we'll do cin input. Okay, and then we will call our expand function. Okay, it's going to remember it's going to return our newly created array. And we have to pass it the old array. We have to pass it the new value, and then we have to pass it the length. Okay, so old array is equal to the old array, the new value, and the length. Okay, so what's going to happen is that this function is going to create the new array. It's going to delete the old one, and then it's going to hand back to main. Right? It's going to hand back the address to the newly created array. Well, why don't we just reuse the original pointer? No reason not to. Why not? Okay, so that's what's going on here. All right. So let me do a compile sanity check just to make sure that everything's working so far. Oops, it would help if I actually provided a function identifier, right? Okay. Alright, so it compiles. Alright, so let me write a helper print function here. Helper print function. And, you know, it's just going to be a print function like you've probably seen me do before that prints the contents of the array for us. Okay. A few lines of code. Alright. So, we'll just call it R and length. Now I'm worried that I might have an off by 1 error here. Okay, we'll test it to double check. Might have to fix that, but let's take a look. I think it'll be okay, but let's try it. So I less than length, I plus plus. Cout R I will put a space in between each element that we display. And then finally, after the array has been printed, we'll put a couple lines here. All right. So it's printed every single time. Print R and length. Okay, and before we exit, we have to clean up our mess. Right, we have to do our garbage collection. R, and we'll reset it to 0. Okay, just to be safe. All right, so this should work. Okay, so this length variable is going to increment by 1 each time because of this statement right here. Right, and that's going to help us. That's going to make sure that the correct length of the array is always stored inside main here, right? So whenever we pass the array to the expand function, this length variable will always be up to date, and so our print will work and our expand will work and all that kind of jazz. So that's why that's passed by reference. Input is the value entered by the user. Old array is basically it's the previous array that has the contents of the array up to that point. Okay. All right. So let's try this thing.